Hi guys, my name is Aishwarya. My MySys number is M01035110, and this is a quick demo for my UNO card detection project. It's a Python based project that detects and recognizes UNO cards in real time using computer vision. Now, this system handles both image based and webcam based detection. It uses the SIFT algorithm for identifying the numbers or the symbols of the card, and it uses HSV color masking for identifying the card colors. As you can see, the code is modular with each of its features being handled in separate scripts, so this helps understand the code a bit better. And before showing the output, I'll quickly show the detection pipeline as well. So, firstly, you would be having car detection, wherein you check for contours in the input frame, and the largest contour with 4 points will be considered as the card, and you sort of get a top down view of the card with the help of the walk perspective transform. After detecting the card, you move on to color detection. Here, you convert the card from RGB to HSV, which is better for color detection. And there are some predefined HSV values with which we make masks for the card. And that is done using the cv2.inRange function. From that, you try to calculate the highest pixel count. So that will be the dominant color. And once the color is identified, we move on to feature matching with the help of SIFT transform. So it's scale invariant feature transform. What it does is that we have a set of templates that you can see in the repository. It's nothing but binary versions of the UNO cards. So these are pre-processed cards, and based on these cards, the SIFT algorithm, it helps in generating certain key points and descriptors from those cards. So once that's generated, it's stored, and later on when you're doing a real time detection from the webcam or from the image uploaded, even it tries to match these stored key points against the current card. So once the matching is done with the help of brute force matcher and Lowe's ratio test. So they try to find out the best match between the card and the template, and that is how you try to figure out what number or symbol it is. So once the symbol and the card color is detected, you try to display it on the output over here, output frame here, and yeah. Now let's also see some areas of improvement. One thing, there is a lot of image processing happening per frame, which slows down the output. You can see later on in the video. And yeah, that's one. This another thing is that there is a mix up between the numbers 6 and 9 and 1 and 7. Then later on, we also do face a little bit of confusion between the colors green and yellow, again pertaining to the lighting aspect. So now let's take a look at the output as well. For that, you need to clone the repository, navigate to the UNOCAR detection directory, and install the requirements. It's nothing but NumPy, OpenCV, contrib, Python. That's all. And we will just run this little line over here. Yeah. So this interface pops up. Let's do upload image. Let's try which one? Let's try yellow one. Yeah. So here you can see this is the original image and this is the warped perspective. Here it doesn't make much of sense because the card was originally captured at the top down view itself. But once the warping is done, I've also tried to do a little bit of dilation. Why? Because for the other colors, the red, green, and blue colors, I was able to detect the numbers against those backgrounds. But for yellow, particularly, there was a low contrast between this background yellow and the number white, the number that's in white. So a little bit of dilation helped in identifying the number on the yellow cards as well, which is why this window is here. Right. So let's also take a look at another color, maybe somewhere it does get confused. Usually it does get confused between a 6 and a 9. So let's try blue 9. Yeah, here you can see that the 9 is being confused as 6, mostly because I think maybe the dilation might have sort of confused this portion of the card as well. Again, things to work on. Now, once we saw this image detection, let's also see the webcam based detection as well, which is a bit more satisfying. I have you. It works best with a neutral background, so I have chosen a folder over here that you can see now. Yeah. Right. So here's the folder. I'm just going to keep the cards one by one. So yeah, it does get confused over here with the 9 and the 6. Let's try another card. Let's try blue 6. Yeah. Let's try 5. Yeah. The yellow is a little bit of a problem. Let's try green. Green 6. Let's take another number. Let's do 5. It is upside down. Yeah. And I think blue. Let's not try blue maybe. Yeah, so you can see that it works well with the, in this case, it's actually working well with most of the numbers. Just that some of the colors do get a bit confusing. And yeah, you can press Q to exit the window. And obviously, the next step of the project would be to lean towards a machine learning perspective, because that would again decrease the image processing needed. It will be a little less heavy, and the detection could be more accurate and robust as well. So that's all for the project. Thank you for watching.